Alright, welcome back. So in this video, we will be talking about the data set itself. So, so this is actually the breast cancer diagnostic data set, right? So it's actually computed, all the features are computed from a digitized image of a fine needle aspirate of a breast mass, right? They describe characteristics of the cell nuclei present in the image. So yeah, I suppose we can just skip to the features, right? So attribute information, we have the ID for each ID number to just try to number all the rows, right? All the data. And we have the diagnosis itself, which serves as the output. It has two values, malignant and benign, represented as M and B respectively. And this is precisely why it is called a binary classification, as um, row data, each row shall be classified as one of those two, right? So yeah, and we will do a binary encoding in which those two values shall be assigned to zeros and ones, right? So malignant will be assigned to one, and benign will be assigned to zero. Um, we will be explain. We will be. I shall explain why it is naturally necessary later on. Okay. So, and then we have all the features, right? So 10 real value features computed for each cell nucleus. So yeah, um, we have the radius, right? Mean distances from the center to from center to points on the perimeter. Okay, so it is actually mean, because perhaps like the cell nucleus you know, um, isn't actually, yeah, like the distance to from the center to like the perimeter, isn't actually the same. So like it has to be a mean, right? So the texture, standard deviation of grayscale values, the perimeter, the area, the smoothness, the compactness, the concavity, the concave points. So yeah, uh, the symmetry and the fractal dimensions. And there are actually three separate values for each of those features, right? So we have the mean, the standard error, and the worst or largest, the mean value of the three largest values, right? So uh, resulting in 30 features essentially. So if I could just, yeah, there are 32 columns. The first one is obviously the ID number, the ID here, and then the diagnosis as well. And we have all the rest of the features, right? From radius, texture, perimeter. Okay, so there's actually a bit of a description here, like right here. Okay, so yeah, this dataset can be found online. So yeah, okay, so as we can see here, we start from the mean, right? The mean values of those 10 features, and then we move on to the standard error values of those 10 features, and last but not least, we have the worst or largest mean value for um, those 10 features. Yeah. Okay. Okay. And yeah. Okay. So next, we will be talking about how to pre-process all these data.